For inviting me to come talk. My titles are all negotiable. As a researcher, I went to ANSA, but I was really looking for an opportunity. I had been promoted, which is nice, to help, but I realized, and for both my warp drive and torpedoes, and it turns out I do, in protecting people. And as David mentioned, it in the community, trying to move for the state. And then we'll get into the stuff that I'm doing with this. I want to highlight two areas of robotic manipulation where my got me, and then starting at A&M. I had one of the first, that one that's on the far, that's what a Robonaut looks like, and then below that is, and that one is now in the Smithsonian, the Air and Space Museum. Humanoid really being built in Japan. People coming to visit us from Asia, and it was a really great effort, and did a bunch of really interesting manipulation. We had using telepresence, where you kind of step into the robot to teach the robot. And we would put a tool in front of the robot, and a person would teleoperatively grab the tool repeatedly. And the system was watching how they did it. And then maybe 5 to 10 grasps was enough. And this was in like 2003. Maybe 5, 10 grasps was enough. And then we could move the wrench, and the robot would autonomously grab it. So that was our idea of how to teach the robot by showing it from within. And who here has ever tried to coach children in sports? Right? Or just coach anybody, right? If you could step into a person and show them, form, you can't really, it's hard to show force and contact, but you can get them 90% of the way there. If you could kind of, normally what you do, like with little leaguers, you try and hold the bat as they hold the bat and show them. But it's awkward because you're trying to reach and hold the bat at the same time they're holding the bat. It's hard, right? But if you could step into a robot and show it form, then that's not a bad start. So that was our thinking. And our motivation was that a robot would be in space and it's facing a problem that we had never thought of. And so we would have it's not a digital twin, but an actual twin on the ground. And we would teach it how to solve the problem on the ground. And then, remember the movie The Matrix, where the heroine needed to fly a helicopter, and so she kind of called for somebody to do something, and then her eyes kind of twitched, and now suddenly she knows how to fly a helicopter. That was the idea we had, that you would teach with the robot on the ground a new skill, and then you would upload it to the robot in space, and now it can do whatever it needs to do. So we did that in 2003 with a DARPA program with Robonaut, and it was really an awesome effort. And it was a little difficult at JSC. At NASA, Johnson Space Center was originally the home of human space flight, and robots are not real popular there. So I was the robotics guy at JSC, and that was always kind of fun. But it was well received in the rest of the world, and we made some really good progress there. The DARPA program connected us with 10 universities around the country, and it was really a good effort. We were really looking, after several years, we had some new ideas. We built a second unit, so Robonaut 1A and 1B were both built. 1B was portable, we could move it around, put it on different lower bodies. Which was kind of fun too. And back then I was the only one who called it Robonaut 1 and Robonaut 1A. Everybody thought that was crazy, but the General Motors Corporation saw what we were doing, and in particular safety around people was an idea that we had for manipulation that's strong enough to actually do work, but safe enough to do it in a trusted way right next to a human. And so General Motors asked us if we would do a partnership on Robonaut 2, which we, of course, said yes to. And the result of that was an amazing series of patents. We produced 60 patents on the Robonaut 2 program, a lot involving sensing to detect accidental contact with people and making sure that the robot is stable and safe. And then you see, in general, the robots are tending to be smooth and not a lot of sharp edges. My wife got me into the morgue across the street. I studied a lot of bone shapes and the way skins flow on bones, and it really had a big impact on me on making everything smooth so that there are no pinch points for working around people. But really the key was a lot of deep sensing that we had that could sense and detect contacts that shouldn't be there and then have the robot pause. So we, we did that, and then we got a call to take one of those Robonaut 2s to the International Space Station, and all that extra sensing that we put in was really the key to getting it allowed on the International Space Station. It was the first computer-controlled machine that implemented a set of requirements that NASA had invented. And when they invented the requirements, they weren't thinking about even a robot, much less a humanoid robot. They were just thinking about what you would, all the levels of redundancy a system would have to have before you would let it run right next to a human without another human holding his or her thumb on a red button. So essentially you're giving the e-stop button to the robot. What would the robot have to have in its design to be trusted? And now, trust in AI is a big thing today, right, in autonomous systems. What would the robot have to be trusted to operate near an astronaut? And we answered that question. We came up with 3 independent ways that the robot could sense and detect a contact, an accidental contact with an astronaut, or even, for that matter, just sensitive equipment. It's bad form if robots bump into the furniture and mess things up, right? So we just wanted a robot that was very sensate and able to detect contacts. And we patented that idea. We ended up with 3 independent ways to measure contact, and we jokingly called that 3-law safe. Kind of a robot joke, Asimov joke. So we had 3 different ways to detect contact, and that was really key. Then we started working again with DARPA on some other humanoids with biped locomotion, and that's where we built the Valkyrie series. And Valkyrie was really built from the ground up, literally from the ground up, to be able to walk against gravity. And that robot it had to be a little smaller than Robonaut, tougher than Robonaut because it was going to fall, smarter than Robonaut. So we decided it clearly needed to be female. And so Val was about 5'10", 128 kilos. And quite strong, great battery, really, really good battery technology, and a lot of really good machine learning. We built a set of 5 that we sent around to universities. So we had a call for proposals from universities, and we sent 5 out to university labs, which was, it's a like $2.5 million superhumanoid robot, and the professors were really happy. But then we monitored the robots, and I'll tell you, I don't know if I should name names, but there's a university in the Boston area that starts with an M and ends with a T, and the one that went there, we were monitoring her, and she was not getting up in the morning and going to class. And her professor had gotten, right after he wrote a really good proposal what he was going to do, but then he took this gig with Toyota and kind of sidelined some of his plans with the Valkyrie, and so she was not getting the kind of attention from her professor that she needed. We were watching the other ones, and they were getting up every morning and doing things and learning new tricks and skills and capabilities, and we were pulling all that software from all the universities and trying it out on our robot that we had down at NASA. So we were starting to kind of build this collection of robots where we were learning from them, except for that one. And so we decided, we pulled her out of that university and sent her to a group in Pensacola called IHMC, and that was a really good fit for her. And that was the group that was writing software for the Boston Dynamics walking robots, and you've seen a lot of their videos. So in the same lab, we had a Valkyrie and an Atlas, and so that was a great place. And that robot quickly caught up with her sisters, and had a really good experience there. We learned a lot. So then I left, and I came to A&M, and one of my objectives is to build a modular set of robots. My PhD work at UT Austin was on modular robot arm design. And I've, since then, you'll see I've expanded my thinking to also mobile robots. But I wanted to go build a modular set of components from which we could build basically any arm that I see needed in space. And so when I left, that was my goal. And I told the A&M leadership that was what I wanted to do. And they said, well, we'll give you the money to go do that. And they've been very generous. But I said, no, we probably need like $80 million to go do this. Yeah, but it helped me go find that. And we have. So with Space Force, we now have a wonderful project that we're called the Space Modular Manipulator Project. And we are now cranking it out. So let me show you a video. Let me see if this plays. This was maybe, 2 weeks ago? Baby's first steps kind of motion. So that's a really strong joint. That's like 400 pound-feet of torque kind of a joint. And look how smooth it is. Just beautiful, two motion. So that's, for a medium-sized robot, that might be the elbow. For a large robot, that might be the wrist. For a small robot, it might be the shoulder. It depends on the size of arm you're trying to build. But at the core of it is that soft control law that I was telling you about that made robots safe around people. So take a look at this. Here's a graduate student, this young man, Stephen Hester. He's doing his PhD with me. And he's going to just shove that joint, and it has 160 to 1 gear head on it. And it's very torquey. And if you were to move it around, it's basically a workout machine. It is so hard to move it around. It's not very back drivable, and it's really high power. But what I want you to watch is how effortlessly and how quickly he can shove it around. So as he's making contact with it, it is sensing that and basically running away from him, because it's programmed to have no torque. So if you're pushing on it, it feels torque, so it runs away. Kind of like power steering in a sense. So let me play this and show you how he can just kind of shove this robot around. And it would take 2 hands to back drive this thing. It's a really torquey machine to grab it and move it around. But just with one hand, he can just manhandle it very easily. That's the level of torque control that we're really going for. And it allows safety. It allows really high quality motion in space. It allows us to do a lot of things that just pre-programmed motion would never allow. So that's kind of my work in manipulation. Now, a year from now, we'll probably have a couple new arms built from these modules, and it's very exciting. So another area of my research has been in mobility, and they keep complaining rovers, but that's just dies hard. So this is a whole series of rovers that me and my team built over the years at NASA, and then some new kinds of mobility systems that we're working on. On the far left was the big Chariot rovers we built, and that machine was built in 11 months. We put a team in a room and kept everybody away from them for about 11 months, and they designed and built that machine, about 15 engineers. And has anybody seen the car show Top Gear? Yeah. British car show Top Gear? So they came and had a great episode on this vehicle, and they drove it around, and we let them drive it without us in there, but we had an emergency stop button behind it and used it aggressively. But they said that it was the best vehicle they had ever driven in their lives after driving that around. And it's a really nice episode. If you check on YouTube for Top Gear and NASA rover, you might find it. We put a cab on it, so you see in the lower picture kind of a big cabin on it. So that's a pressurized rover cabin that could go on that chassis. And that really revolutionized the way we're thinking about exploring on planetary surfaces now. The thinking was, to get to a pressurized cabin, you'd have to have something the size of a Winnebago, a massive, like Elvis's bus kind of a scale machine. And we showed that you could build something down on the scale of, it was about 10,000 pounds. And being able to rove around in a shirt sleeves environment versus inside a spacesuit is going to change everything. You are very fragile when you're in a spacesuit, and the operational timeline is you're on a maximum 8-hour kind of timeline. So you really are on a short leash, and on that leash, you're nervous, and the suit is just beating you up. My friends who have done spacewalks, they say that it's a privilege, but not a pleasure. And for the gentleman in the room, I'll tell you, it hits you in all the wrong spots. It really beats you up. One of my friends lost fingernails, and he's halfway through the spacewalk, and he's worn a fingernail off of his hand. And he still has 4 hours to go, and he kept going. I mean, these guys are heroes, but it's not a pleasure. So if you could ride around in a shirt sleeves environment, you could also be a little more focused. And so we did a human factors hypothesis-driven experiment on that, where we judged the science production of two people in suits driving the same chassis in an unpressurized mode, where they had to wear a suit, versus being in a more comfortable environment and looking through the windows. And then periodically they would get out, maybe only for 30 minutes, and then get back in. And we showed at least 100% improvement in scientific value, because as you're driving along in a suit, and you can, it's very focusing. You're living in a suit. They drove right by some of the best samples that they could have ever found in the field. Just sailed right by them, not noticing them because they were in the suit that was just beating them up. So we think the pressurized rover, small pressurized rover, is really going to be a key invention. And then we went back the kind of top center. That was a project with a, you see there are no logos on it, but it was a project with one of the big car companies in America. It has a two-letter acronym. And developing some new ideas for electric and driverless vehicles. So we applied some of our rover ideas to that. And on a completely unrelated topic, has anybody seen the e-Hummer? Crab steering, active suspension, an amazing battery. Huh. Yeah. And then we tried a number of different ideas on suspension, and we actually applied the spring designs that we developed for manipulators and Robonaut to the suspensions of these rovers. So the fact that we were having manipulation research going on at the same time as rover research really is important. And if you think about it, the human arm, it's been traced back. There's a great book called Your Inner Fish that I recommend. It traces back the genetic form of the human forelimb. Big bone, two bones, series of small bones, 5 chains of bones. That code traced back genetically through embryology and in the fossil record back to a fish 600 million years ago-ish. And that fish had really good fins, and it ate all the other fish. It was really fast and good. And later, that structure became a leg. So if you look at quadrupeds, the forelimbs are a suspension, and if you think about a cat pouncing, the way it absorbs impacts, it's kind of like a suspension. And so I really like the idea of looking at both manipulation and mobility and applying similar ideas and trying things, and we had the opportunity to do that. On the upper right is a prototype of the Viper rover that was designed for the moon. Again, active suspension. and able to operate in soft soils. Now, since coming to A&M, we've had a couple of mobility projects. The top one is brand new. It's a mini version of that big Chariot. It's a 6-wheel version, but it's only 200 pounds. And at NASA, we didn't publish anything. We had all these amazing algorithms that were developed for using the active suspension and climbing through sand, kind of swimming. None of it was published, much less even really studied. So my grad students have built a mini version of it, and working with the NASA engineers, we're going to go through, redevelop all the code, describe the code more in a parametric way so we could scale it for different size rovers, and publish some of these ideas so that the rest of the community can learn about it. And so that's a mini Chariot, and the young ladies who are building this thing have decided that in that class, all of the rovers are going to be named after dogs. And I don't know why they decided that, but the first one is the Robotic Exploration Vehicle, REV, which is named after the A&M mascot, Reveille. I'm pulling for Rastro. I think that's got to be, I'm sorry, Astro, but maybe that's the next one, but we'll see. And then lastly, on the bottom here, we've got a completely different kind of mobility system. And let me play a short video. We've got one of the students here. If you want to learn more about it, we can tell you about it. So, see those two balls? Those are robots. And the small one is 2 feet in diameter, and the medium one is 6 feet in diameter. Why didn't I call it a large? Because it's Texas, and that's only a medium. So, how do you think those things work? You think there's an undergrad in there? Well, there's a whole taxonomy of spherical robots and how they move. And some move by winching a mass around that moves where the CG is, kind of amoeboid motion. Very tedious, lots of motors, slow. There's another series of them that use gyroscopes. They are very quick and nimble, but they tend to saturate when you run out of top speed of the gyro. The class that we're in is the pendulum class, where there's a pendulum hanging from an axle, and when the pendulum lifts up, it causes the ball to roll forward, and then it can lean left and right. So it ends up having only 3 moving parts. Now there's some mixes. There's some with like 1 pendulum and a gyro. But one thing that we're doing that no one else is really doing is the soft rind, the shell itself. And again, one of the things I learned is, it's a hard world, and so having a soft robot is a good idea. If you come into gravel with a plexiglass ball, it's terrible. It does not handle soil well. So the pneumatic tire is a miracle. It's an amazing thing, and basically we built a pneumatic spherical tire here. The other thing we added in the 2-foot ball, we have a complete pneumatic control system where we can, once you charge it with air, it can air itself down and re-air itself up. And the way it does that is it has an internal compressor and an internal tank. And so when the compressor runs, it takes the air that's in the ball and puts it in the tank, which reduces the ball pressure. And then when you vent the tank, it reinflates the ball. So you don't waste any air. You just kind of move it around. And our latest research has changed the treads that we're putting on the ball. And at about 3 psi, the treads go away and it's smooth. But then when you air down to about 1 psi, the treads reappear. And believe it or not, if you go to our website, you'll see videos. This thing can drive on water. Both of them drive on water quite well. The 6-foot ball is pretty high up. The 2-foot ball rides at about 40% in the water, and the 6-foot ball is probably like 20% in the water. It rides up pretty high. And the original motivation for that, the first one of these I built was at NASA, but I don't have a really good picture of it, in 2003, was to drive down into a crater. And some of the craters on the south pole of the moon are just enormous, the size of Houston, and very dangerous and cold. But figure a beach ball should get to the bottom quite nicely. And then, of course, there are some other applications with it being aquatic. So that's a glimpse of my research, past and present, at NASA and at Texas A&M. I might just one other mention. I generally don't like having undergrads work with me during the fall and the spring. And sorry, there's no offense, but at A&M you have to get really good grades your freshman year to decide which department you get into. It's competitive, and it's really competitive. And so they're all admitted as general engineers, but then they get, it's kind of like a match where they rate their top 5. Is it 5? 3, top 3, and then we kind of do a match. And for you to get your number 1, you have to have a good GPA. So I tell all the freshmen when they show up in September in my office, I don't want to see you. Go away, go study. What are you doing standing in my office? You should be studying. And the summers are for having fun building robots with Dr. Ambrose, not the fall and the spring. So in the summer, we had 36 undergrads last summer as part of our intern program, and we're going to do it again this summer. So the summer experience is totally different. No homework, right? We didn't have any homework. We worked, but it was all in the lab, no homework. And had a great summer, and the summer before that we had 24. I think we're probably going to plateau at 36 for a while. And great summer program, and building a lot of robots and collecting data. It's been a lot of fun. But in general, I don't want the undergrads, because the kind of students I like, they'd throw themselves into one of my projects and then flunk calculus. And then I would have on my conscience that they flunked calculus, they didn't get into the department they wanted. It's all because, Rob let them work in the lab, and I can't have that on my conscience. All right, so now let's talk about the state. So enough of robots. So recognize somebody in this picture? Big tall guy in the back. So this was in March. So the governor announced the nominations or the appointments for 2 things: the Texas Space Commission and the long name consortium. The acronym is TARSEC Consortium, Texas Aerospace Research Space Economic Consortium, TARSEC. So David and I are on the consortium, and there are on the commission there are 3 nominated by the governor, 3 nominated by the Speaker of the House, 3 by the Lieutenant Governor, and on the consortium there's 2 from each of those political offices. And then there's the rep from Rice, the rep from A&M, and the rep from UT. So that's how we've formed our consortium. All institutes of higher education are eligible to become members of this consortium. We were nominated to be the executive committee to help organize it. So what are we doing? Well, the number 1 purpose of this whole effort is to make sure that Texas remains number 1 in space. And if you think about what the state has done for space work in here in Texas, not much. Texas, the state has bragged about space. Texans. I'm a Texan. We're very good at bragging. But other than bragging about, Houston was the first word said from the moon. Home of human space flight. We're awesome. You guys suck. Whatever this, that's, bragging is one thing. But the states now realize they might need to do more than that, and they are getting very serious about this. So they looked around, they saw it's a really competitive world. And if you notice, space is kind of having a moment. And where we come out of this moment is not, the space ecosystem is not going to look like it looked 10 years ago. It will not all be run by NASA. There's a lot going on commercially. Even the work that NASA's doing, they're farming it out to commercial groups. So things are changing. But more importantly, there's just a bunch of innovation where most of the stuff was within the government. Things were not changing very quickly, but we are now seeing a rapid evolution of capabilities, of whole new ways of doing things. And it's kind of like in the 19th century when the tycoons got into rail. That was kind of an indication that rail was having a moment, right? It was becoming a big thing. And have you noticed there might be a few tycoons who are getting into space? We don't call them tycoons. I guess we call them billionaires, or I call them billionaire rocket enthusiasts. And there's a lot of their activity, and that's a clue that there's some things going on. And so we wanted to make sure that they happen in Texas. That what would happen is if all the innovation and all the new ideas are happening in, I don't know, let's say Oklahoma, then eventually what is here in Texas might atrophy, and people would move to where the action was in Oklahoma. And anybody here from Oklahoma? I got a lot of family from Oklahoma. My dad was born in Oklahoma. Sorry, Oklahoma sucks. We do not want all the innovation and the new stuff somewhere else. And it's really not about Oklahoma. It's mainly about other countries, frankly. And so a few other states, but mainly it's non-friendly countries that are doing things. So the state decided to put some money where its bragging mouth was, and in the last biennium allocated $350 million to go get some things moving in space. And I consider this just a down payment. Now, we have to do some good things with this money, or else maybe it'll just be one and done. So David and I are under a lot of pressure to try and make sure that this investment gets well utilized. They split it into two categories. One was a direct appropriation to A&M to go build a new building that I'm going to tell you about. And that was for $200 million, and it's going to be an amazing facility here in Houston. And then the remaining $150 million was set aside in a research fund. And your faculty just spent a bunch of time writing proposals to go after these funds. And our expectation is that in the next biennium, that fund will be replenished with a new batch of funding, if not grown. Here's some metrics. That $150 million, since it was put in the bank, it's grown to $158 million. That's good news. As of a couple weeks ago, when they kind of closed the application period for the first review, against that $150 million pot of funds, 176 proposals were written for $2.7 billion. Now, after my over-under was $3 billion, that was what I was guessing, and I hear they've now crossed that because people didn't get the note that it was closing 2 weeks ago, so they're still writing proposals. And they're going to be reviewed. They'll just be reviewed in the next batch. So I think we're over $3 billion now. So what is that? Is that a 20-to-1 oversubscription? So 5% probability of win. So it's competitive. That's a pretty competitive call for proposals. And they were in 5 areas. They were in research, emerging technology, infrastructure, curation, and workforce development. So those are all pretty big different categories. And I don't know how you try and compare a workforce proposal to an infrastructure proposal, to an emerging technology proposal, but that's what they've got to do. They were going to announce the first awards on Tuesday. We just heard today, is that right? That's been delayed. So it's hard to review. Anybody been on a review panel for proposals? So what's a typical, when you do a review, John, how many are assigned to you as a reader?
5, 6. 5 or 6. If we're more, it's maybe 2 or 3.
So do the math on that. If there are 176, and how many reviewers is it good to have per proposal?
Oh, at least 3.
At least 3, assessments, right? So that's a lot of people to try and get through them. And they've had 2 weeks, and they're, I think they were a little surprised by the number of people that turned in proposals, but I'm optimistic. So while we're waiting to hear on the first batch of proposals, let me tell you about what we're doing with that other funding. The strategy was really developed with a couple of these key leaders. So this is Vanessa Weish. She is the center director at the Johnson Space Center. And she had an actual strategy. Who here has sat through workshops to come up with strategy? She actually had a strategy. And her strategy was, okay, yes, there's going to be a lot of new development, not at NASA. And she had 240 acres on the west side of campus, so she made it available. If you're going to go work on some new things in space, she's going to give you some real estate to do it so that it happens, guess what, in Texas. Pretty clever. And so that's a new idea. And part of that was that, who here has been to the Johnson Space Center? Who here has gone to the Johnson Space Center where you had to go in and get a badge? Was that a very simple and easy process? Anybody feel good about that process that they went through to get a badge? Yeah, me either. And over my career, it just got more and more onerous, right? And I can draw a line into the future, and I would say it's going to get more onerous. So we're moving the fence in. So not only are we going to build buildings on the west side of campus, the security perimeter is being moved in. And so we will have our own rules, and they will not be as onerous. We'll have rules. No designated countries, for example, but no 6-week lag to get a badge. Yes, John? So what is across the street? So across Saturn is Space Center Houston. Space Center Intermediate Middle School, where both my kids went to middle school. So that's the site that we're going to be building on. And with the fence moved in, it'll be easy for us to get people in. It will allow for collaboration. We're going for collaboration of industry, academia, and government. Especially in our science missions, we have researchers, co-investigators from all around the world. And we treat them terribly when they show up at the front gate. This is very difficult to get them in. And so we are going to be a much easier place to allow that. So again, Vanessa Weish had this strategy. And then over here is one of our local representatives in the state legislature, Chairman Bonin. Now, in Texas, to be a member of the legislature, I think they pay you like $7,000 a year. I think, something like that. So they tend to have day jobs. So it's not a full-time position. And Chairman Bonin, his day job is he's a spine surgeon and a pretty sharp guy. And he grew up in the Houston area and is a big fan of space. And he's really the key guy behind the move to, let's not just, we'll keep bragging about it because it's Texas, but we will also put some money in and go try and move the needle. And so Dr. Bonin was really the force behind that. He's the chairman of the appropriations panel in the Texas House. And then this is the Speaker of the House and Governor Abbott. and you see cast behind. Let me call out one person between the speaker and Chairman Bond and Nancy Curry Gregg. So when the state appropriated these funds to A&M to go build this building, A&M created this political entity within A&M called the Texas A&M University Space Institute that will manage the building. So we've created an organization that will go get the building built and then take care of using the building. And so Nancy is the director of our Space Institute, and I'm her associate director. So Nancy, anybody familiar with Dr. Nancy Curry Gregg? Initially, Nancy Sherlock. She was an astronaut, flew 4 times in space. She's literally my favorite astronaut. I know a lot of astronauts, and I've told them this. Nancy's my favorite. She was also a colonel in the Army, flew Apache helicopters. And she's 4'11" in heels. And I will say this until someone proves me otherwise. She's the most economical person that has ever been flown in space in terms of weight, oxygen consumption, water, food, storage of all her clothes, on and on and on, and she's amazingly sharp. So if all astronauts were like Nancy, we'd probably already be to Mars. You can quote me on that. So we announced this, and we've gotten busy. But in the meantime, we've been working on this new building. This is, as John was saying, it's on Saturn Lane. And the way we explain this at Texas A&M is this way. So if you look at kind of a plan view of the building, it's got these 2 large scapes. It's got a lunar scape and a Marscape, and down the middle is a more conventional building that has labs and offices. But each of the scapes is about 2.5 acres, which is about the size of Kyle Field plus some end zone seating. And I was at the game on Saturday with some friends who were wearing a lot of orange. And it was a good game despite the fact that A&M lost. It was so it's a really big building, and we think that the logo on the roof will be visible from space. These things matter. All right, so let me show you a fly through of this. Can you guys see that? So this is coming in from Saturn Lane, kind of heading north into the building. There'll be visitor parking there. There's no gate, so the guy that shows up with aluminum foil on his head at the NASA gate, they'll direct him over to our so we're going to have security. And so you will have to have a badge to get in. Well, we can open the front part of the building for public events like hopefully a professional seminar series. When you come inside, there's an atrium lobby. Up on the 2nd level, there's an exhibit deck. And right away, we just want to show you, there's like a bridge extending out, a balcony out, looking out onto the Marscape. 2.5 acres, quite large. There's an exhibit hall. We're looking for artifacts from the space community to put on display there. After 20 plus years in the government, it's going to be great that I can actually serve wine and cheese there at events. Then to punch out, let's go to the other side and take a look on the Marscape. So 85-foot ceiling, programmable lights. We can adjust the Mars sky. Sometimes it's a little bluish, sometimes it's tan. We'll be able to program for different seasons. And you see, looking back at the central part of the building, just a whole series of first floor labs. We're calling them garages because they roll out onto an apron and then to the scape. And garages sounds cooler than labs. And then there is a wormhole where you can drive from Mars to the moon. And it's about 100 feet. It's very efficient, so we've got to find wormholes. And when you come out onto the moon side, Notice that it's different. We're going completely blacked out, and when we're really doing a test, it will not look like this. When the lights are turned out and everything is blacked out, you will not be able to see your face in front of your hand in front of your face. And then we're going to set up a light down low and turn it on ultra bright, and then you won't be able to see anything. And that's the way it is when you're driving around on the South Pole. So this is one of those garages. And for my whole career at NASA, I was trying to figure out how to put engineers together with their robot or their whatever. And this is kind of the latest evolution. There are these mezzanines where all the engineers can be there, so their desks don't have to be somewhere else. They're really set up to build a team in one of these garages. And on the second level, there's this connecting tunnel. As you walk down, you'll be able to look into all the garages and see all the cool things, or not. Some of these will be commercial operations, and they might close their blinds if they're doing something proprietary. The A&M garage will be open. And then up on the third floor are just a bunch of modular rooms. We're calling project rooms. Here's one configured like a classroom or maybe a workforce training room. And then on the third floor, there are these long hallways on the outside connecting all of the project rooms. So with the glass railing, you'll be able to remind yourself every day you come into work that you're on Mars. Here's one of the project rooms configured as an office complex. So it's a series of cubicles and closed offices and some conference rooms. And then through the center of the building, we've got these light tunnels flying through that. Here's one of the rooms configured like a laboratory. So again, we're building this building for 60 years. We don't know how people will be wanting to use it in the year 2084, but we want to make sure that it's versatile and easy to use and reconfigurable. You look down there, you see that bridge that we'd come out onto from the second level on the exhibit hall. But up on the third level, at the end, is going to be an awesome auditorium. And it also has balconies looking out onto both escapes. And it's a reconfigurable space. It's got seating built in the back, step seating, and then a big open floor that can be reconfigured from ballroom dancing to robot competitions or whatever. And then again, a bridge where you can go take a look at both the Moon and Marscapes, which might be a little distracting. As people are giving talks or whatever, you'll have to forgive the audience if they're daydreaming looking out at Mars, but I think that's okay. So that's the building that we're building, and we will be moving in September of 2026. So any questions? Dave, do you want to field this question?
Yeah. What's the difference between the extra-terrestrial versus the Martian?
Yeah, so it's mainly lighting. And we're going to have a different aggregate on the ground, but it's mainly lighting. So Martian lighting is, overhead every 25 Earth hours. You get, the sun overhead. For a lunar South Pole mission, which is what most of the missions are that we're going to be helping with, the sun goes around the horizon, never gets more than about 5 degrees above the horizon. And if there are mountains there, and there are, it often goes behind the mountains. And so we're going to black everything out, and then we're going to set up a 50 kilowatt lamp down in one corner, low, looking sideways, blasting sideways. And who here has driven into the sun in the evening? That's going to be what it's like. And even walking is going to be difficult because it's going to cast terrible shadows across a grayish landscape. And if you ever do look at it, I hope that visor is good because you might have to stop for a couple minutes and let your eyes recover because it might not be safe to walk if your eyes have overly dilated or contracted. We right now think it's going to be pretty hard on the robots too. Cameras bloom when they look into the sun, and we're kind of worried about driving and walking in those kinds of lighting conditions. So we'll have a great place to try it out. Other questions?
Amy online, if you have any
So, besides the two scapes, is there a larger test bed, test area for the robots that's not themed in either of those? A more open environment, maybe more configurable, if you want to test some slopes or some harsher environments?
Yeah, so we have some outdoor rock yard areas at the Johnson Space Center. But and in fact, I was responsible for the JSC rock yard, and my goal was to put it out of business because it was horrible. And I spent most of my time there in August just because of the way the fiscal years work. Most projects are done in September, so testing in August. And believe it or not, Clearlake is slightly more humid than Southampton in the Museum District. I know that's hard to believe, but it's slightly more humid and brutal in August, and lots of rain and squalls coming in off the bay. And but yeah, we'll have an open area where if you need to do some other drives, but we think we can do 20-degree slopes. So the facility will have a whole set of electric construction equipment, so electric bulldozers and front loaders where we can grade different slopes. And yeah, they will not be fixed. So it's on the moon side, we have already identified the quarry, and we're now debating which scale of the aggregate to get. But it's a quarry of basalt out near Uvalde, and it's very similar, maybe even be the same kind of basalt that was ejected and formed the moon. We are purchasing 150 rail cars of it. I don't. We looked at a rail line to this building, and it was impossible. So we've identified a couple depots that are down in the Clearlake area. But it's a lot of aggregate. We're still looking for the Mars side, and it's really complicated. It's got to be somewhere between burnt orange and maroon. It's really complicated choices on the Mars sides. But so on the Mars side, different kind of lighting. The terraforming will be different kinds of alluvial kind of structures versus craters. So those would be the differences, and we will have outdoor access to. Yeah. So on the second floor, there is a break room. My thought is I think it should be on Mars. And so we're looking at some 3D printed building structures with some companies in Texas. And I would like to 3D print a Martian cafe. That'd be nothing's permanent, but it'd be a semi-permanent habitat module we could have out on Mars. And then I guess we might need to provide food there, or maybe other things there. So maybe the answer is on Mars.
Yeah, would you try to compensate? I know Mars and the moon have different gravity field than the Earth, and would you try to model that somehow?
Yeah, so over in at JSC, my former division built some gravity offload robotic systems that it's basically an overhead robot that picks you up, weighs you, and then you dial in how much you want to weigh, and it takes n minus that off. So if you want to weigh 1/6, it takes 5/6 off, and as you walk around, it's holding 5/6 of your weight. And so it's a robotic overhead gravity offload. It's programmable. 0G is the hardest, but we use it for training spacewalks for space station right now. But 1/6G and 3Hg, which is Mars, is programmable. So we're looking at different ways to build that into the scapes, but we are not providing that initially. So what I would like is my former division to be given the job to go build that, and that's what I'm hoping happens. and I don't want to, so I don't want to go reinvent the wheel. I think there's a group there that can do it. And if I built a bunch of specialty equipment into this building, instead of a 2.5 acre moonscape, we'd have like a 1/2 acre moonscape. So what I'm trying to do is keep it simple, make the building as big as possible, and then we'll have 60 years to add things to it. So no clean room. If you want a clean room, we've got a technical RV park, laydown yard in the back. We can bring in portable skiffs, portable clean rooms, portable MRI, portable test equipment, and bring them in the back and hook them up. We have power and data hookups. And all that stuff goes obsolete as soon as you buy it. So rather than build it into the building, certain things like that will just have to come in. And then the companies can outfit. We think we're just the first. We're building a $200 million building on the corner lot, and that's got to do good things for the local real estate.
If you think about it, with NASA, with the universities, particularly UNM, and with what's happening with Spaceport, as you said, this is a really, really good time to be thinking about space and so we're really kind of excited about it all, and this is going to be amazing.
Yeah, and so if you, see like that habitat module, that could be a Mars Cafe. See that back wall? That's phase 2. We can add a whole series of garages on both the Moon and the Mars side, and just cut into that wall. We've set aside green space outside where we could build even more. And 60 years is a long time. I didn't want to try and pre-think everything that people would do in the building. Most of the buildings at JSC are 60 years old, and they would be shocked at what we've been doing in those buildings. They would be shocked that they're still standing.
Yeah, so I mean, this is a fantastic facility, and it's operated by Texas A&M. But how do you envision either private companies or other university in Texas taking advantage of the facility? So what will be the interaction? If I want to use one of the garage, what would I need to do?
So a couple things. So state funds given to a university to build on federal property with commercial companies renting it, or as we say, simple. That's actually not simple. But we expect most of the garages are going to be rented out to companies. And we've already got a bunch of companies who want to do it. We're hoping, we're holding a couple for NASA, one on the Moon side, one on the Mars side. And then A&M's going to keep a couple. And we're going to keep those so that we can say yes to a professor who wants to go do an experiment for like 2 months and needs a place down there. We'll be able to say yes, because we'll have a couple that are just set aside as flex space. The companies are all going to do like 5-year leases, and professors can't really think about a 5-year lease of a garage, right? That's kind of hard to imagine. But we will have a couple set aside for collaborations with friends, where we can say yes very easily. And what you might do, you might be building up something down on the Scape, but it'd be nice to have a place to store your stuff, not leave it out in the yard, and have a garage, garage space to be useful. Now that said, don't store your stuff in my garage. I got 2 sons, they're storing their stuff in my garage all the time, and I'm on to you. If you want to store stuff in the garage, no. It's valuable space. We'll get you a rental, storage unit somewhere. But right. But for active users, we will have a couple bays set aside where we can say yes to some short-term interactions without a lot of paperwork. And David knows my default setting is yes. So if someone comes and wants to go do an experiment there, we're going to say yes and then go figure out how to make it happen.
And I don't know if you said this, but is it, you're going to have 20 of those garages?
Yeah, there'll be 20 garages.
And I think I have a question from online. I don't know if Lily or Roman's going to read it out, but tell us who's asking the question.
Get over there. Hang on.
Is it, do we just have to, do we have one or more, more than one question or just one?
We just have one.
Okay, so if you just tell who it is, Lily, and then ask the question.
So Danish asks, in order to become an astronaut, from your description of Nancy, do we have to have a military background? Like to apply for the astronaut program, do you need military experience of any sort, such as Marine or SEAL?
No. So NASA hires a lot of people from lots of walks of life. And did you guys see who just got nominated to be the new NASA administrator? Commercial astronaut, flown in space twice. So, a lot of people are going to be flying in space, and it's not like in the 60s where it was only fighter pilots. I think it's the world's evolving.
Can I get three? So being involved in commercial R&D in the past and government R&D, privacy and security are huge. Will you be able to segregate sections of the actual main regolith areas off?
Yeah. So good question, and here's what we've come up with. And it's a work in progress. Our answer is a work in progress. Okay. So talking to the companies, some of them are more concerned about proprietary, confidential secretness than others. It seems like the ones that are ahead want everybody to see it. So they're all open kimono, but we want to be able to work with anybody. And what we're thinking is that out in one of those scapes, like on the moon side, we will preserve like a track around the outside of the regolith, of the simulant. There's a kind of an open. So my model is a field and track. Anybody been to a field and track tournament? So around the outside is the track, and in the middle there's the pole vault and the long jump, and the javelin's got a lot of room. And so what we're thinking is we will preserve a public area around that all the tenants get to use. And I would be okay if there was 2 rovers on that track on one day. It's not going to break my heart. If they can just not run into each other, I'm good with that. But then they will each have their area, and if one team has just spent the last 2 days grading a perfect 22.5 degree slope, and they're about to run an astronaut up or throw an astronaut down it or whatever they're going to do on that slope, they don't want someone else coming over and messing up their slope. Right? They've graded it and got it all measured, and it's ready for their test. So they need a zone that they can use. And then the other thing that we're thinking is that each of the tenants will have a certain number of nights per month where they're the only ones there. And if they want time during the day when they're the only ones there, that's got to cost them something. And it really ought to cost them something from the other tenants. And since they will all be in the same position, no one wants to be kicked out of their garage for the next 3 days because their neighbor wants to do something confidential. That's not very neighborly. So we're going to try and get people to use nighttime, after hours, for confidential work. If they have to do it during the day or longer term, I tell people I work from home 2 days a week. It's called Saturday and Sunday, and I think they should just try and do it on the weekend. And if they really need to do something like 48-hour test or something.
But now they can say the work from Mars.
Yes.
So second
2 days a
question,
week.
Regina would like to know who the architect is. She's an architect.
Yes. So it's publicly known. We selected a design build team, so it's a combination of energy architects and Vaughn Construction.
And my final question, how can we get involved and help make this a success?
Well, there are going to be a number of things that we make available to the public. Clearlake really needs a professional seminar series like what you're doing here. We don't really have something like that in Clearlake. So I'm hopeful that we will have more of a community opportunity for people to come to the facility and participate in talks and workshops that we can have there. But as far as looking for student or research opportunities, if you are working on something that could benefit from a facility like this, give me a call. I would love to be a part of your proposal, and it won't necessarily be me, but it, using the facility. Well, yeah, maybe on Mars. And if anybody's doing fermentation research, we would definitely want that. Yes, yes.
Okay, I think this guy has to drive the conversation. I have to feed him first, so I'm going to call him. So please join me. You can see there's a lot of exciting stuff going on. Rob's at the heart of a lot of it, not just on the research side, but what we're trying to do with the state. So please join me. Thank you. A couple of quick announcements. If you go to space.texas.gov, there is an opportunity to input to the Space Commission. Our committee will try and do some. We've had a couple of workshops that are open, and we're hosting a couple more. But there's an opportunity to put in your ideas. If it involves aliens and foil caps, I think there's other websites I would point you to. But if you have ideas of what you think the state should be doing, either from your own interests or your company's interest, or just your general interest, they're soliciting ideas right now, space.texas.gov. We are hosting a couple of other events over the course of the next couple of weeks, if you've got time. Pumps and Pipes is over at the Helix on Monday. I think you can still register for that. On Tuesday here at the Higgs Hudspeth Auditorium over at the Continuing Studies, we're having the first ever US-Japan Space Forum. And so we'll have Mitsubishi and Toyota and then some NASA folks and Intuitive Machines folks represented there. So you're welcome to join that. And then on the 18th, we're still waiting to get the flyer out. My friend Andrea here. We're working with the Italian Consulate General Office to have we did this last year, but we're celebrating the Italian National Space Day on December 18, and that will be more later in the afternoon. That will be in our corner building. So look out for ways to sign up for those events too. And if I don't see you, enjoy the holidays, be safe, and have a great time with your families, and we'll see you in the new semester.